Welcome to our new video tutorial series on Mathematics Grade 10. Now we're going to tackle about review on polynomials. First, I would like to set a disclaimer that some of the parts of this review comes from mathematics, where I find their review or their way of teaching polynomials very satisfying and easy to understand. So let's start. First is let's answer what is polynomials. So let's put a big question mark here to answer what are polynomials. Now, to answer that question, we need first to understand what are terms. Terms are mathematical expressions that are made up of two parts, the number parts and the variable part. They are sometimes intended to be multiplied with each other. But since multiplication is intended in algebra, we don't need to put a multiplication time between them. So just put them next together. To explain the number part, we can say that the number parts are just numbers. It could be 1, it could be 6, it could be 1.5, could be 1/2, and so forth. And we have a special name for this number. We called it coefficient. The variable part is somehow tricky. We can say that it is composed of one or more variables that is raised into power. Take note of this. It should be raised into power to consider it as a variable part of the polynomial of a term. X squared is an example. Y is an example. As you can see, we cannot see any number that serve as the exponent of y. That is because y is always raised to 1. We don't just put 1 because it is the identity of y. So it's just saying that y is y because we raise it into 1. So no need for us to write that. Another example is x squared y squared. So they are both raised into power, and they are both variables, and they could be part of the terms. Now, if we talk about polynomials, polynomial is a combination of many terms. It's like a chain of terms that is connected by addition and subtraction. Now, we have some special name of polynomials. Though it is not polynomial, it is also nice to learn about one term monomial. So we call it monomial because it only has one term. Next is binomial because it has two terms, a trinomial and a polynomial. Polynomial means many terms. So as you can see, we could also consider binomial and trinomial as a polynomial. Now, we have now defined a polynomial in a very basic way. Polynomial is a series of terms joined together by addition or subtraction. Now check if this example is a polynomial. Now we can see that 3x squared contains a number and a variable that is raised into power. So we can consider this as a term. But how about x? Does it have a number with it? And does it have a number and is x a variable that is raised into power? Yes, it is, because x has an invisible 1 here because 1 is the identity of multiplication. So meaning if we multiply 1 to x, the value of x doesn't change. So that's why no need for us to write 1. With regards to the exponent, I explained it a while ago on y. The exponent of x, or if you can say an exponent, it has an exponent of y, 1 here. Because 1 doesn't change the value of x, no need for us to write 1 as an exponent of x. So this x is a term. How about 5? Is 5 a term? Okay, now I want you to look 5 like this. So if this one is x raised to 2, this one is x raised to 1, we can consider 5 or the constant 5 as 5x raised to 0. Since any number raised to 0 is equal 1, So this somehow equal to 5 multiplied by 1. But since 1 is an identity of multiplication, it doesn't change the value of 5. So because that's the case, it's more convenient to not write this one beside 5. That's why we called 5 as a constant, because any variable you place next to it is raised to 0, and that doesn't change the value of 5. So all of these are terms, and they are connected by plus and or subtraction. Therefore, this is a polynomial expression. Now, a polynomial expression is an expression in the form of this, where the non-negative integer n is called the degree of polynomial, and coefficient a sub 0, a sub 1, up to a sub n are real numbers. So meaning, this one should be real numbers, and this one, the exponent, should be a non-negative integers. So what are non-negative integers? Non-negative integers include 0, 1, 2, 3, and so forth, as long as this is a whole number. Well, we cannot consider 1/2, 3/4 as an integer. So meaning, if there's a variable, the exponent of the variable should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember example a while ago about negative 5. 5 has an x that is raised into 0. So that's why this is also considered as a term. So now let's put that in action. Let's try to answer this question. Following questions. Number 1, is this a polynomial? The answer is not, because of this term, because of this part. So any number that is raised into negative is equal to 1 over that number raised to the positive of its integers. Meaning, this one doesn't coincide with the definition of polynomials. It says in the definition that the exponent of x should be a non-negative integer. So this one is not a polynomial. How about number 2? The answer is not polynomial because of this. Remember that a variable that is inside a root is equal to x raised to 1/2, because this one will serve as the index, and this one will serve as the exponent of x. So this is equal to square root of x raised to 1. So this makes it not a polynomial because it is raised into a fraction. Unless a fraction could be simplified into a whole number. In this case, it is not. Number 3 is a polynomial. All variables are raised into a non-zero integer, non-negative integers. Same as well with number 4. It's somehow confusing, but all you have to do is to multiply it with each other, and you can see that the exponent of x is a non-negative integer. Now let's go to the degree of polynomial. The degree of polynomial is the degree of terms with the greatest. The degree of polynomial is the degree of the term with the greatest degree. And how is that possible? Imagine this example. Letter A, 11x raised to 7 plus 3. Now find the degree of each term. We can see that 11x7 has a degree of 7, and 3x cubed has a degree of 3. Therefore, the degree of polynomial is 7 because 11x raised to 7 has the highest degree. On letter B, we have 1/3 w squared z plus 1/2 z fourth minus 5. Again, same step. Let's find the degree of each term. So 1/3 wz has a degree of 3. As you can see, there are two variables here. W has an exponent of 2 and z has an exponent of 1. So if this is the case in one term, if it has two variables, all you need to do is to add the exponent of those variables. In this case, 2 plus 1 is equal to 3. That's why the degree of the first term is 3. The second term, 1 half z raised to 4. Z has a 4 has an exponent of 4. Therefore, the degree of it is 4. And 5 is 0. So therefore, the degree of this polynomial is the greatest degree, which is 4. Now, there are special terms or special names for a polynomial that has a very specific degree. If it has a 0 degree, then it is a constant. If has a 1 degree as its highest, it is linear, just like x squared x plus 2 is equal to 0. This is a linear. On the second if it has a on second degree, we call it quadratic. Example of this is x squared plus 2x plus 1. And if it has a third degree, it is cubic, quartic, and quintic. In grade 10 in the Philippines, we just focusing on this cubic, quartic, and quintic in our polynomials. So much for that. Now let's go to some of our activities. Sorry. Now let's determine whether the following expressions is a polynomial. Number 1, no, all of them has a non-negative exponent, so this is a polynomial. It seems confusing on number 2, but it's actually can be written like this. So this is considered as a number part, x squared. So this is a polynomial as well. In number 3, the second term has a variable on the denominator. Again, if we have this kind of term, to change it, we could put it in the denominator and change the sign of the exponent of x into negative 1. So therefore, it is not a polynomial. Same as with number 4. We already tackled this, that inside a radical, a variable has a fraction exponent. So this is not a polynomial. Again, in this case, this is a special case. We cannot consider as a variable as an exponent of a term. So this is not a polynomial, and this is a polynomial. Now let's classify the following if it is monomial, binomial, trinomial, or polynomial. Now imagine this. To separate each term, all you have to do is to check for a number and a variable. And if it has a sign next to it, then you just slash it. Then count it 1, 2. The sign of it will goes to this term. So it is its sign. So this is a binomial. This is a binomial. 1, 2, 3. So this is a trinomial. This is a monomial. 1, 2. This is a trinomial. Oh, 1, 2, 3, 4. This is a polynomial. I'm sorry. 1, 2. This is a trinomial. So that's how we classify it. The terms of a polynomial expression will be written in any order. However, for a polynomial that contains only one variable, we're usually written in standard form. Now, the standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to least degree. When written in the standard form, the coefficient of the first degree is called the leading coefficient. Now, let's try to do this. Let's consider this polynomial. Let's transform it into standard form, and let's get the leading coefficient. So again, let's divide them into degree to their terms. Number 1 has a 1 degree. The second term has a degree of 5, and it says in the third term is in second degree, and it is into 0. Now, if we're going to write it, let's put first the highest degree, which is 5. Again, take note of the sign. This sign belongs to this term, so we should put negative 7x raised to 5. Next is this, plus 4x raised to 2, plus 6x plus 9. See this? If you don't see any sign here, then it is understood that this is positive. Unless there is negative here, then you will put negative here. So in this case, this is the answer. Now, again, the leading coefficient is the coefficient of the first degree if the polynomial is in standard form. So our polynomial now is in standard form. Therefore, our leading coefficient is negative 7. Okay? Okay. So let's go to our next activity. Now, find the degree of the polynomial. Again, let's divide this into terms. This one has a 0 degree, 1 degree. The exponent of this is 4, so this is 4th degree. Now, the exponent of this term has two variables. We have a and b. The exponent of a is 3 and the exponent of b is 2. So you need to add that. 3 plus 2 is 5. So the degree of the polynomial is the highest degree of a term that it has. So it is 5. Number 2. Let's try to do this. The degree of this is 2. The degree of this is 4. So number 2 is in 4th degree. Now write each polynomial in standard form. Then give the leading coefficient. Okay. Number 3, let's divide it first. So the degree of this is 3, 0, 5, and 2. So let's put 5, 3, 2, and 0. So we have 7g5 plus 24g3 minus g2 g squared plus 10, and 7 is our leading coefficient. And number 4, let's divide this again. Look at this, it has a highest degree. It has 4, then 2, then 0. Remember that the sign of this belongs to this. So we have negative x raised to 4 plus 3x squared plus 14, and the leading coefficient is negative 1. Again, we don't put 1 here because that's understood, but if it's a variable, there's always a 1 here. So that's why that is negative 1. So that's all for this tutorial. Hope that it helps you on your review on polynomials. So see you on the next tutorial video.